Hi, and welcome to S for Science. And to watch this video, you're using the internet. But where's the internet? This is a somewhat difficult question to answer. We all know the internet. Its exact definition is that of network of computers interconnected with each other around the world. This definition, however, has recently had to adapt to new technologies, given that now we have internet in many other devices apart from computers, like mobile phones, tablets, and a long list of other devices. And where is this video, for example? YouTube is headquartered in San Bruno, San Mateo County, California, so it would make sense for them to install their main data center there, right? Well, it's not like that, and for a very curious reason. The San Francisco area is located on one of the most unstable areas in terms of seismicity, the San Andreas Transform Fault. Every 100 years in that area, a devastating earthquake occurs that is usually of a huge magnitude. The last of this occurred in 1906, so scientists believe that the next one would be imminent. That's why, despite the fact that a large part of the companies dedicated to the internet are located in Silicon Valley, ironically, almost none have their servers there. Most of the data is stored in large data centers that are hidden in areas with a cold climate, cheap electricity, and high security. One of the largest servers that Google has in the world is the Hamina, located in Finland. This place meets the ideal conditions to be an excellent data center. But how is it possible that these data, which are stored in Hamina for example, or in your closest server, arrive in just tenths of a second on your screen? If you're from South America, for example, you should know that your closest data center is in Quilicura, Chile. Facebook also has its headquarters in Frankville, Oregon. All your friends, all your photos, all your comments that you have been making throughout your life on Facebook, they're all there. But where does this information travel at such high speeds? As you well know, light is the fastest thing that exists. Its speed in the vacuum is 300,000 kilometers per hour. An extremely high speed. When the internet was designed, something very fast was sought. Initially, copper cables were used, but then they were quickly replaced by optical fiber. Optical fiber is a spectacular material since it allows information to be transmitted at the speed of light. But how does optical fiber work? It's a very simple invention, but at the same time it's extraordinary. Optical fiber is made of cables of a reflective material, whether it is glass or plastic, which allows these cables to conduct light almost infinitely. The fact that it allows information to be transported is the most impressive advantage of this technology, since it allows information to be transported at the speed of light. But how do we transform light into usable information? You should know that most computers and machines around the world work with binary code. A code that is based on ones and zeros. That is, all the information that is in your computer, all the images, all the videos are written in ones and zeros that the computer can translate. The fact that there are only ones and zeros allow optical fiber to be used to transport digital information. But why? Because simply by interpreting, for example, a 1 as light and 0 as dark, we already have an intelligible code that can be transported. That is, if there's light, 1, if not, 0, and that's it. This is how that much information can be transported at such an extreme speed. If we saw it with the human eye, we would only see a very slight flicker, but computers have adapters that allow them to process this information very quickly. And that rapid blink is quickly transmitted into ones and zeros, which then is transmitted into information. But how did it all start? We are now on October 29th, 1969. At the University of Los Angeles in California. From there, a connection was established with the Stanford University in San Francisco. On that day, the first internet connection was made. They attempted to send the word login, but it was only possible to send the L and O, since there was a problem in the receiving computer's memory. However, that was the first message that was sent over the internet. But how did this great invention evolve over time? This is a map of a small part of the internet, where each line between nodes represents a link between two IP addresses, and their length is proportional to the delay between them. The remarkable thing about this map is the incredible number of connections and servers that exist, in addition to the curious form that it takes, that resembles the neural connections that exist in our brain. This other fascinating interactive map, whose link you have in the description, shows the number of visits received by the world's web pages, representing it proportionally with the size of the circles. Clouds of different colors are formed, where each one represents a language. And in this other spectacular map made by Facebook, the unions of some friends around the world who are geographically separated and who use this social network are shown with blue lines. Internet has changed the world. It has been a revolution in a list of unnumberable things. The amount of information that circulates through the network in a single day is spectacular, which is equivalent to 168 million DVDs. Another spectacular fact is the amount of emails that are sent in a single day. If they had to be sent by hand, it would take 2 years. We now see that the internet is very large. The amount of information that is sent every day is amazing, and everything is done at an extremely fast speed. But where does all this information go through? How does it travel? How is it arriving to your screen right now? What you see on this map are the places where the gigantic fiber optic cables that are submerged under the waters of the whole world pass, and that allow us to send emails, check Twitter, or watch videos on YouTube. These cables connect to the main cities around the world, and once they reach the mainland, they branch out into smaller cables that branch out again several times until they reach your house. It can be said that these cables are the Achilles heel of today's society. In fact, there are incredible security measures that make these cables practically indestructible. They are resistant to earthquakes, ocean currents, possible tides, and sharks. Yeah, sharks. Something that has been taken with some humor until this video that you're watching right now was recently recorded, in which a shark appears giving a bite to one of these cables. Obviously, the cable didn't receive any damage. The most fascinating thing of this is actually thinking that what you're seeing and hearing just a few tenths of a second ago was traveling at an incredible speed, 4,000 meters below the surface of the sea in the middle of the ocean. So we have already seen that the internet is not really in a specific place, but is spread all over the world, stored in some servers. Some of this information is stored in transistors, some electronic components that obviously also work with binary code. They can store a 0 or a 1 based on the electronical charge that each have. If an electron is present inside a logic gate, it is no longer conducting, causing it to be a 0. A 1, in the other hand, is produced if there are no electrons, which makes the transistor become conductive. Flash memory transistors have a second gate called a floating gate. This one traps electrons to maintain the value of the transistor, even when there is no current. So really, the internet is nothing more than a few electrons circulating in a specific way. Well, more than a few, a lot. In fact, if we put together all the electrons that make up the internet, all those electrons that are inside the transistors, and that mark us ones and zeros, that is, that mark us all the information that is stored in all the servers of the world, if we added that weight of all those electrons, the entire internet would add up to the incredible amount of 50 grams. The same as what this apple weighs. So the internet, as it is, really weighs 50 grams. Thank you very much for watching the video, and goodbye.